Problem solving. Problem solving is one of the most important fundamentals of math. It's basically why math is required no matter what your major is. And word problems are the types of problems that exhibit problem solving, word problems or application problems. Now, if you get a little anxious when you see a word problem, the following steps may help you relax and walk you through it. Step number 1, make sure you understand the problem. This can be done by organizing the information given by sketching a diagram, constructing a table, or just rewriting it, relating the problem to maybe your past experiences or visualizing yourself in the problem. Not just understanding the problem, but also make sure you have a clear understanding what the problem is asking you to find. A lot of application problems have more than one part that they're asking for. Once you know exactly what you have to work with and what you're trying to find, derive a plan how to solve the problem. You may try a few things, jot a few things down, you might just work it out in your head. Once you figure out how you think the problem needs to be solved, carry out your plan, solve the problem, but don't stop there. Make sure your answer seems reasonable. If it's not reasonable, that means you either made a mistake in your work or your whole plan or the equation you came up with was incorrect. Make sure you include or answer every single part of the problem, including any and all units. Now, word problems are all typically solved a little bit different, all different from one another. That makes them a little bit more difficult to solve. It's a higher order of learning. But they're all based on deriving an equation or setting up an equation. Once you have it set up, then it's just a matter of solving the equation. And like I said, they're all a little bit different, but sometimes they can be categorized into specific types. For instance, one specific type is what I refer to as a geometry problem, just some problem that involves a geometric shape. So example 1 here. The third side of an isosceles triangle. So as soon as you see a triangle, you know it involves a shape. An isosceles triangle, more specifically, a triangle that has 2 equal sides. So the best way to organize the information in a geometry problem is to sketch out the diagram. It's only for your benefit, so it doesn't matter how nice it looks or how straight your lines are. In an isosceles triangle, we have 2 equal sides. And once again, just from the first sentence, it's telling us the third side is 2 inches shorter than each of the other 2 sides. So we know we need a variable somewhere. That's usually our starting point, x, which I'll set equal to the 2 equal or congruent sides. That means the third side being 2 inches shorter, I can write in terms of x as 2x, or excuse me, x minus 2. Next, it goes on to tell us the perimeter of the triangle is 67 inches. Now, perimeter, key word you should pick up on is the sum of all the sides. So the perimeter we know is going to be equal to side 1 plus side 2 plus side 3. So we already have a structure or backbone of an equation. If we go back in and substitute in the values we know, we're not asked to solve the perimeter, we're given the perimeter of 67 inches. Side 1 we set equal to x, side 2 x, and side 3 x minus 2. So now we have a linear equation with only one variable, which we know how to solve. So take a few minutes, solve this equation. X works out to be 23. Now we solved the equation, but we have not solved the overall problem yet. Make sure you have a clear understanding what x was equal to in the problem. We set x equal to the 2 congruent sides. So keeping in mind our unit was inches, so 23 inches by 23 inches are the 2 congruent sides. The third side, 2 inches shorter, is 21 inches. Take a quick check, make sure it seems reasonable. We have 2 equal sides. We have the third side 2 inches shorter. And the perimeter of a triangle, 23 by 23 by 21, would be 67 inches. So everything checks out, so we should be pretty confident we have this problem correct. The next type of application problem that can be categorized into a specific type is what's referred to as a consecutive integer problem. We know what integers are, positive and negative whole numbers. In other words, all your numbers not including decimals or fractions. So what we're asked to find here are consecutive integers. Could be 2, could be 3, could be 4 consecutive integers, could be consecutive even integers, consecutive odd integers, whatever the case may be. But the overall concept here, we have 3 missing numbers, and we're trying to find 3 numbers. So that's how we're going to set up the problem first of all. And our starting number, the first unknown number, is going to be our reference point x. For the second unknown number, second consecutive integer, we're going to represent as x plus 1, and the third x plus 2. For instance, if x is equal to 7, the second consecutive integer, 7 plus 1 is 8, the third consecutive integer, 7 plus 2 is 9. So what the problem tells us we're doing with these three numbers is adding them together, the keyword sum. So x plus 1 plus x plus 2 is equal to 186. And as we see already at this point, we have a linear equation with one variable which we can solve. We solve the equation for x, keeping in mind that x was just the first unknown number. So if x is equal to 61, that means the next consecutive integer, 62, the third consecutive integer, 63. So yes, we have three consecutive integers. Take a quick check. Is their sum equal to 186? Yes, it is. So once again, we should be pretty confident we have this problem correct. The third type of application problem, a motion problem or a distance problem. Something moving at a particular speed or rate for a certain amount of time is going to travel a distance. So in order to work a problem like this, you have to know the distance formula. D is equal to R times T. It's a linear equation, but a linear equation with three variables. We can only solve a linear equation with one variable. That means the problem will give you values for two of these three variables, allowing you to solve for the third one. So you read the problem, it should be pretty easy to recognize one of these. Distance is equal to rate times time. In this case, 300 miles, of course, is distance. Substitute that value in. 6 hours, of course, is time, which leaves us the remaining variable r to solve for, which works out pretty well because that's exactly what they're asking for. What was her rate for the trip? So, of course, we typically write that as 300 is equal to 6 hours, so pretty easy to solve. Divide both sides by 6. R is equal to 50. Include your unit. Distance is in miles, time is in hours, so rate miles per hour. So let's look at a few more examples. Example 1, another consecutive integer problem. In this case, the sum of four consecutive even integers is 508. So we have four unknown numbers in this case. The first unknown number is always our starting point, x. But we're not just looking for consecutive integers, we're looking for consecutive even integers. For instance, 2, 4, 6, 8. So if our first unknown integer is x, the second consecutive even integer we're going to represent as x plus 2. We need to skip over the odd number to get to the next even number. The third then, following the same process, would be x plus 4, and the fourth consecutive even integer, x plus 6. We're still being asked to add these four together. So x plus 2 plus the third, x plus 4, plus the fourth, x plus 6 is going to be equal to 508. Once again, a linear equation which we can solve. X works out to be 124, where x in the problem was once again just the first unknown integer, 124, which makes the next one, x plus 2, 126, the third, 128, and the fourth, 130. So we have four consecutive even integers, and if you add them all up, they do add up to 508. Example 2 does not fit into one of these categories that we've covered so far. It's just kind of a general word problem. You just have to pick up on the keywords, convert them to mathematical symbols, and so forth. So read the problem, understand what's going on. Overall concept here, once again, you have two unknown numbers. X, our variable, would be our reference point, or the first unknown number. It says the other number is 5 more than twice that number. So twice number, you're multiplying by 2. 5 more, add 5 to it. And we're adding these two numbers together, so x plus 2x plus 5 will equal 80. A linear equation with one variable, solve it. Solve for x. X is equal to 25, which was just the first number. Plug that value into the formula for the second unknown number. 2 times 25 is 50, plus 5 works out to be 55. So we have two unknown numbers. Their sum does add up to 80, and one is 5 more than twice the other. Example 3. read the problem, understand what's going on. It's certainly not a geometry problem or a consecutive energy problem. It's a motion or distance problem, so a little bit more going on though than the first motion problem we looked at. There's basically two parts, or two things moving. So if we sketch out, make a little diagram, see what's going on. The first person here, Lance, is biking east, so he's going to be biking at a certain rate for a certain amount of time. We'll travel a certain distance, so we use the distance formula for him. What we know about his trip is that he's going 25 miles per hour, so we can substitute the rate into his formula. Then we have another person, Levi, traveling west. So we're going to have to use a distance formula for him as well. What we know about him, first of all, is he's biking at only 20 miles per hour, and he leaves an hour later, so his time is going to be 1 hour less. The last piece of information in the problem is that we want to figure out how long it takes for them to be 250 miles apart. So these two distances that they travel must add up to 250. So the first distance we know is equal to 20 times t minus 1. The second distance is equal to 25t, so if we add those two distances together, they should equal 250 miles. When we sketch it out, we see that it's a linear equation which we can solve. T works out to be 6. T, of course, stands for time, but we have two different times. T was the time it took Lance to bike until they were 250 miles apart. What we're asked for in the problem is how long it will take Levi to bike until they're 250 miles apart, keeping in mind that his time will be 1 hour left. So 6 minus 1, the final answer to the problem is 5 hours. How long it takes Levi to bike until they are 250 miles apart. And example 4, read the problem, understand what's going on, deals with a geometric shape. So once again, another geometry problem, sketch it out. Rectangle we know is made up of a length and a width. What it tells us is that the length is 9 times as long as the width, so you can set up a couple different ways. Use X, or we'll just go ahead and use W for the width. That means the length 9 times longer is going to be 9W. Once again, the perimeter is the sum of all the sides, a length plus a width plus another length plus another width. In other words, the perimeter is going to be equal to 2 times the length plus 2 times the width. So we substitute in these values. The perimeter is 160. The length we set equal to 9W, and the width we just left as W. So a linear equation with two variables. We can simplify and solve. The width, or W, works out to be 8, which makes the length 9 times as long, equal to 72. The unit is both feet, so the dimensions of the rectangle, 8 foot by 72 feet. Take a quick check. The length is 9 times as long as the width, and if you had a rectangle 8 feet by 72 feet, the perimeter would be 160 feet. So we know everything checks out. We know we have the problem correct.